Because of this rule, we can create a formula which tells us that the number of moles in a sample is equal to the mass of that element or compound divided by its MR. So if we want to know how many moles there were in 42.5 grams of ammonia, we would do 42.5, which is the mass, divided by 14 plus 3 times 1, so 17, which is the MR of ammonia. And this would give us 2.5. So we know that there are 2.5 moles of ammonia in the 42.5 grams. We can also rearrange the formula to find the mass if we were given the number of moles. For example, what's the mass of 3 moles of carbon dioxide? Well, this time we'd multiply our 3 moles by the MR of CO2, which is 12 plus 2 times 16, so 44, which gives us 132 grams of CO2. We can also work out the mass of a particular element within a larger compound, like the mass of carbon in 3 moles of carbon dioxide. For this, all we do is take the number of moles, which is 3, and multiply it by the MR of the carbon, which is 12. So 3 times 12, which gives us 36 grams of carbon in our 132 grams of carbon dioxide. And if you wanted to go one step further, you could subtract that 36 grams from the original 132 grams to find that there must be 96 grams of oxygen, because we can see that CO2 is only made up of carbon and oxygen. Now, the last thing we need to mention is that when you look at a chemical equation, you can think of them in terms of moles. So for this equation, we can think of 1 mole of magnesium reacting with 2 moles of hydrochloric acid to form 1 mole of magnesium chloride and 1 mole of hydrogen gas. And you should think of these as ratios. So if we started with 2 moles of magnesium, we'd have to react it with 4 moles of hydrochloric acid, and it would produce 2 moles of magnesium chloride and hydrogen gas.